Alright, I'm going to go ahead and get started. My name is Grady King. I'm a programming mentor for Mars. And I was also a programming lead and driver a few years ago. And we're just going to go over WPILib basics and moving a motor. So WPILib, it's University or Institute in New York. That's what it is. And they make this library. They've been making it for years. And they make Java, C++, and LabVIEW, and I think Python also, which is crazy. But we use Java because it's a lot of people learn about it in school, and it's pretty useful. And yeah. So in general, you're going to need WPILib VS Code and the CTRE offline library. You don't necessarily need Phoenix Tuner X because it's just useful for what I have here, but you need those two. And our general goal for this is to move a motor with Java code, but how? If you just have Java, it's not going to work. So what we're going to use is something called CTRE libraries. These are CTRE products. This is a Falcon 500. It's one of the most common motors in FRC. The other major brand that you might see is Rev. We don't necessarily use Rev anymore because of like some weird issues. So I'm just going to go over CTRE for this one. And we're going to be using WPILib as the structure, and that's the structure that every robot in FRC uses, pretty much. But yeah. So we're going to go ahead and launch VS Code. So it's going to look like this icon. I'm just going to go ahead and open it. And it's going to look exactly like VS Code that you might have seen before. But there's this little button at the top right, and this is the WPILib control command palette. And this is where you're going to do miscellaneous things like creating a project or doing some configuration or something like that. So I'm just going to go ahead and click it. And you'll see that there's this list of a bunch of things that you can do. What we're going to look for is create a new project. And so it might just be like hidden down here, but you're just going to click it. And this will start a new project. And yeah, so the first thing you're going to do is select a project type. There are examples that they have. There's a ton of examples. Actually, I can actually show you. There's so many examples that like you can't really go through them all. But they are really good reference points. So if you want like some code to see like an example of something, then that's where you can get it. But we're going to go with a template because we're making actual code. And then there's C++, CPP, or Java. We're going to use Java. And then there's all these different types of projects. The two most common types are command and timed. Timed is actually the more simple version, and so we're going to use it today. Command is something that, I don't know, Sean, can you explain the benefits of command?
Okay, so basically,
yeah.
But you don't really have to worry about that right now.
Yeah,
it's it's like a higher, like it's the next step after you figure out all this.
Yeah, so we'll go over command in later weeks, but for now we're just going to do timed robot. And then it'll ask for a base folder, and this is where your code is actually going to be stored. So it'll just pick up here. I'm going to put mine in documents. And I have a Mars programming folder here, and yeah, you can put it anywhere. You can put it desktop, whatever. And you're going to name your project. So I'm going to call it training number 1 project. And then create new folder just means that it will create a training number 1 folder inside of Mars programming, but it's whatever. And then you want to put in your team number. This is important for connecting to a robot and like a few configuration things that you don't really need to worry about. Our number is 2614. Yours is going to be, what, 95 something? 9475. But yeah, really self-explanatory. Yeah. And enable desktop support is just for some simulation stuff. Don't check it for now. And then you'll just click generate project. And then we're going to, it'll say, do you want to open the project? Yes. Yes, we do. So this new window will pop up, and some things are going to be happening. There is like a terminal down here that's doing some build stuff just to make the project structure, and then I'll start talking about it once it's finished. Takes a while. Okay, so over on the left here, you see this is called an Explorer, and this just shows all the files that are in your project. And the only one that you're really going to worry about is SRC, which stands for source, and that's just the source of your code. And there are two different folders here. There's deploy, which is something you can use to put files onto the RoboRIO. So you make code on a laptop, and then you put the code on the RoboRIO. But there are also files that you might want to put on, like autonomous plays or something like that. And then Java is where you actually put the code. And so in Java, you can see that there are two different Java files. This main is pretty much never going to be changed. Basically, all it does is you can see in this main method, it calls upon this WPILib sort of robot base, which is just the base of a robot, and it's used for every type of sort of robot. And it just calls start robot. And so it's basically just the starting point of your code. But you don't necessarily need to change it. Robot is where you'll actually have the code. And you'll notice that there's already code in here. And this is partly a template and partly code that they have as an example. And we can sort of talk through that. But in general, you can see that there are these import statements at the top. And this is where the code accesses external code. And so what this is accessing is WPILib Java code. And it's going to this thing called a timed robot. And that's just a structure that is used in that start statement to structure it well. And then there's some other things like smart dashboard that you don't necessarily need to worry about. That's just part of this example. And so this will have an external robot, and it's of type timed robot. And then in here, there's going to be all these functions. And these functions will run at different points of time in different sort of modes. So this first one, don't worry about this code up here. It doesn't really do anything. Robot init is the code that runs at the very beginning. So this is code that runs when the robot turns on. And so what you do in here is you could do like configurations and stuff, but we don't necessarily need to worry about that right now because we just have a motor and we just want to do something simple. So we don't necessarily need to worry about that. And then we have robot periodic, and this is a loop that runs every 20 milliseconds, no matter what's happening. So yeah, over and over and over and over. And so that's 20 milliseconds, which means it runs 50 times a second, which is a lot. Things that you might do in robot periodic are like reading a sensor and then publishing it to a dashboard, since you always want to know a sensor position, or like a camera feed or something like that, since you want those all the time. These other modes or these other functions run in different modes. And I can kind of show what the modes are if I open the driver station, because they show up on the left. The main mode is something called teleop. And you can see it's actually the first selected option is teleop. And that means, whoa. And teleop basically just means that you are operating the robot remotely. So this is like basically using a controller, controlling it like an RC car or something like that. Autonomous is something that happens in the first 15 seconds of a match, which means that, and in autonomous, there's no driver feedback, and it's just the robot moving. And so we also don't need to worry about autonomous right now because we are going to just control it with the computer. And then there's also test mode. This is kind of like a something that's optional. You can use it for, I don't know, like if you want to test stuff in the pit, and not necessarily have the same controls that you would have in a match. You can do it in test mode, but you don't necessarily need to do that. And then practice is just actually a combination of teleop and autonomous that times it to an FRC match. So there's 15 seconds of autonomous and 2 minutes and 15 seconds of teleop, but we don't need to worry about that. And so you can see this is reflected in here. There's autonomous. Teleop is actually disabled, which is, I guess, runs whenever you're in the disabled state. When you want to have the robot move, then you enable it. And so then I guess teleop or autonomous code runs. But then when you disable it, it runs different code. And then there's test here. There's also simulation, but we're not worrying about that. So in general, your teleop code is going to go in teleop. Your autonomous code is going to go in autonomous. And then periodic is for those periodic things like reading a sensor or something like that. So now, and I've kind of skipped over my slides a little bit. Now we're going to add CTRE libraries. So we want to move this motor, right? But I don't want to kill it. We want to move this motor, but we don't really have access to any of the libraries that actually make this move. So what we're going to do is we're going to add the libraries that communicate to this motor, and then we're going to call the methods that it gives us. So how we do that is using WPILib. If you go in here, and you go up to the top right here and open the WPILib command palette, there's going to be an option called Manage Vendor Libraries. That's also going to be down in the depths, and you're just going to want to click that. And you're going to have a few options here. If you installed the offline CTRE libraries, then you're going to go to install new libraries. And one thing to keep in mind is that you have to install these libraries in every new project that you make. It doesn't persist. You have to add it to each new project. So we're going to click Install New Libraries. And you'll see that we have Phoenix 5 and Phoenix 6. Phoenix 6 is something they released last year. It doesn't have everything that CTRE has to offer, but it can control Falcon 500s. It can control the new Kraken motors, and like things like the CAN-coder. And so what we're going to do is we're going to click Phoenix v6 and then just click OK. And then it's going to say it's recommended to run a build after a vendor update, and we're going to say yes, because that is a good idea. And it'll just run at the bottom there, and it'll take a sec, and we just have to wait. So now we have our CTRE libraries, and you can check that you actually have it correct. If you go back to Manage Vendor Libraries and go to Manage Current Libraries, it'll show up here. And yeah, so make sure you don't uninstall it, because this is actually, if you click it and click OK, it like uninstalls it. So don't do that. Just click out of it. So now we have CTRE libraries, and now we can start calling the code from the CTRE libraries. And so if we go back here, this is the statement that imports the code that specifically communicates to Falcon 500s. So the motor controller inside the motor is actually called a TalonFX. It's kind of confusing, but they kind of like differentiate it. So we're going to import code for a TalonFX. And so what we do is you want to put your import statements at the top. You can see they're up here. And we're just going to go down here and type in import com.ctre.phoenix6.hardware.talonfx. I know that's like a lot. Now that we have that code, we can start to use it. Let me pull my slides. And so what we need to do is create a variable. and that variable is going to store information about the motor. And this is something that's kind of special to Java in that you create a sort of object, and that object contains information in it. And it also contains things that we can use to interact with that object. And I know that's kind of confusing, but it'll sort of make sense as I go. So at the very top here, this is where you're going to declare these variables. And that's so that you can access them in all the different types of loops. And so we're just going to make a variable, and we're going to call, let's just start with the type. So the type is going to be a TalonFX, and we can call it a name. And this is going to be the name of the variable. You could call it anything. I'm going to call my motor Bob. And to actually assign an object to this variable, we need to make a new one. And you can see a sort of example up here. But in general, we're going to do this variable equals a new TalonFX object. Oops. And you see it's kind of like throwing something in here. And that's because we need you can see in here, it's telling me that I need a device ID. And so this means every motor has a unique ID, and it's one that you set. And I'll show how you set a motor ID. And so each of them have a different ID, and that's how you say which motor you're actually communicating to. Because you won't just have one motor, you're going to have a bunch of motors. In order to see what the ID of this is, I actually need to turn on the robot. So I'm just going to go ahead and do that. And then I need to plug into the computer using a USB-B wire here. And so that's all I'm doing. And then to communicate to these specific motors, you're going to use something called Phoenix Tuner X. And this is available on the Windows Store, I think. You don't necessarily need to pull it up now because it's not going to display anything because you don't have a computer with you. So I'll just pull it up myself. So I had this open before.
We extended the Prime Hub.
Okay. But here we have a few different things. We have this PDP. We have this Talon SRX. And we also have this Falcon 500. And the thing that I'm looking for is the ID. And you can see it's right there. So for this motor, it's 14. We could actually change it. If we wanted to, you can just go into here. I'm going to make it 9 and just set it. And you can hear the configuration. And now the ID is different. And that's just, you'll just set IDs however you want. You can do it completely ambiguously, or you can have a system for it. It doesn't matter. So now we know that this motor has ID 9. And so that's where we're going to put into our constructor here. And so if we go back here, we're just going to put a 9 in here. And then it's going to stop yelling at me. And you can actually see that it labels it as the device ID, which is nice. And so now we have an object called Bob, and it has the information in it, which is that it's the 9th device, or it has ID 9. So now what we can do is we can actually tell this motor to do something. And the way that we do that is we call a function upon Bob. So, and what we want to do is, since this is sort of like something that we might want to, let's just say that we want to do this in teleop. So we're going to put it in teleop periodically. So in teleop, there's you might have noticed that there's two functions. There's the init and there's the periodic. This is something that Sean was talking about. There's the init, which is the initiation or like initial code that runs. And so this code will just run once. And then periodic is something that runs every 20 milliseconds. Since we want a motor to move, we actually want to tell it to move quite often. because you can tell a motor to run once, but then after a certain amount of time, I think it's 200 milliseconds, it'll stop. And that's just so, like, if communication gets cut off or something, it'll stop. So what we want to do, if we want it to continuously move, is tell it to move in periodic. So in periodic here, I'm just going to hit enter to move the semicolons down. And then all we're going to do is call Bob. And so this is our object Bob. This is our motor. And we're just going to call a function with a dot. And the function that we're going to call it, you can see that there's like literally a billion functions. Most of them don't matter. We're going to call set. And you can see that it's telling me that set has something called a double, and it's asking for a speed. And so a double is just a number with a decimal. Specifically in set, it's going to be a number from -1 to 1. And so 1 means 100% forward, -1 means 100% backwards, and then 0 means to not move at all. And so, like, for example, like 0.2 would be 20% forward, -0.4 would be 40% backward. For this example, I'm going to make it move 20% forward because that means it won't like jerk out of my hand, because it will do that. And then we're just going to end it with a semicolon. And in general, that should be it for moving this motor. Basically, all this code is doing is when we're in teleop and we're enabled, it'll tell Bob to move at 20% speed every 20 milliseconds. And so that means that it'll just move continuously. Now that we've written the code, we have to build it. And building is a process of taking this sort of English representation of what we want the computer to do and turning it into a language that the computer actually understands, because it doesn't speak English, it speaks ones and zeros. So that's what building does. And so all you're going to do to build the code is you're going to go back up to your button, and you're just going to find build robot code, and you'll just click it. And this is the same sort of process that happened when we added dependencies. And so it'll take a little bit. Thankfully, it takes less time in Java than it does in LabVIEW. In LabVIEW, it takes like a minute and a half sometimes. But you see it already finished. Now, what we're going to do is we have this built version of the code, and we have to put it onto this computer so that it has the code, because it doesn't have the code yet. So that's called deploying. And so we're once again going to use our button, and we're going to call deploy. You can see deploy robot code here, and you're just going to click it. So now I successfully have robot code running. You can see that in this log, we had initiation of the library, and we also have some diagnostic server running. And that's just telling you that it's all working pretty much. So now that the code is on the robot and it's running, why isn't the motor moving? Well, we don't need a controller. It's telling it to go 20% all the time. I didn't hit enable, yes. So right now we're disabled, so it's not running that code. But
He wants to have it in his hand, otherwise it's going to dance.
yeah, otherwise it's going to dance right. So I'm going to hold the motor, and I'm going to hit enable, and we'll see if it works.
There you go.
Whoa. So that's moving a motor. That's crazy.
Rocket would love that.
And yeah, so we've succeeded. We've moved a motor. Does anyone have any questions on what we've done so far? No? No? Okay, sweet. We're going to add another layer. We're going to use a controller. And so a controller is kind of unique in that it connects to this computer, not to that computer. So what it actually does is it uses WPILib libraries to communicate from this driver station to that computer and like relay the information.
So the controller connects to the computer connects to the robot.
And then the computer connects to the robot.
Okay.
Right now we're connected through a wire. Sometimes we'll be connected through a radio. But in essence, we need WPILib libraries to talk to this controller. So, and one thing is that, because I wanted to emphasize something, which is, which I'm also going to be talking about a little bit later, is that reading documentation is like one of the best skills that you can have as a coder. So if you don't know how to do something, you want to look in something called the documentation, which tells you the capabilities of the library, what it actually does, all that sort of jazz. So if I now open this is an example of the WPILib documentation, and you can see that I want to use a joystick, and I don't have this sort of joystick. This is something that people have used in the past, but is relatively rare now because it's kind of weird and has less buttons. A lot more people are familiar with this, which is an Xbox controller, and you see that we have Xbox controllers, and we use them because they have a bunch of buttons, and a lot of people are familiar with them, and they're super easy to pick up. And you'll notice that there is something called the Xbox controller class, and it tells you how to create an Xbox controller. And so we're literally just going to copy this code because it works great. So we're going to go ahead and copy this. And we're going to create our object here.
This is the first.
And so you can see that it's type Xbox controller, and it says that this is the name of the variable. We could call it, I don't know, we could call it controller. How original. And we're creating a new Xbox, and you can see that there's a port here, and you can actually see what port the controller is if you go to the driver station. So if we go here, and you go to this button down here, you can see that there are all of these ports, these slots. And so you can see you can actually have up to 6 controllers. Normally you use 2 for a driver and a co-pilot because you can't have any more. But you see that this one is at 0, and you can see that I'm moving my my stick here, and the values are updating. And I can hit the buttons, and you can see that it also updates in the POV. So that just means that port 0 is the one that we want. If you want to change where, what port, then you can just drag it around. So I'm gonna put it to 1 and then use 1, because why not? By default, when you connect a controller, it'll be in 0. So you probably want to have your pilot or your main driver on 0. But I'm gonna use 1, because why not? And so I'm gonna change this to 1. And so now we have a controller variable, and it has the information that it's in port 1. So now we need to read information from the controller, and we're going to also do this in tele.periodic because since we're telling the motor to move in there, we also want to read the controller and see what it's what the output is. And actually, something that's convenient is the outputs of these joysticks are from -1 to 1. Which you might realize is very similar to a motor that also goes from -1 to 1. So you can see that as I'm moving this stick, when I move it down, it goes to 1, and then when I move it up, it goes to -1. And so my idea is, what if we just directly map these two together? Have the joystick move the motor. So what we can do is, let's get our controller, so use controller, and you can use dot, and there are, is this a wrong?
No, that's fine.
No, that's fine. Okay, so there are these different functions that get different parts of the controller. What I'm looking for is the y-axis, which is the up and down. There's the y-axis, which is up and down, and the x-axis, which is left and right, similar to like a 2D graph. And so I'm going to get the y-axis of the left stick. And you can just kind of scroll down. And
So you like get left axis or something? I don't know.
isn't it get y? What is it?
Y is going to be the button Y. It's going to be get left stick something. I don't know.
Get left stick.
Get left trigger axis.
Oh, get left
Oh,
y.
wait, no, get left Y.
Get left y.
Okay, no, you're right.
And you'll see that there's no parameters, so we can just go ahead and close the parentheses and put a semicolon. What I want to do is I actually want to see that this is giving me what I want, and this is, you could call this testing or debugging or something like that. One of the simplest ways to do this in Java is called printing, which is obviously super useful not only in this but in like other programming. And the classic way to print in Java is System.out.println, and we're going to do that here. And if you've ever used Java, this is like what you are used to. And I'm just going to take this value and print it out. And I want to print it out over and over so that I see that it's actually doing the thing that I want. So I'm going to put this inside the print statement and then put the semicolon. And so what this allows me to do is I can see what the value is every loop cycle. So every 20 milliseconds, it's going to run this print statement, and it's going to take that value and print it. And I'm just going to go ahead and deploy it, and you'll see what I mean. In general, you don't want to do too many print statements because they're kind of slow, and eventually it'll make your robot too laggy. So you kind of want to do this like temporarily. There are other ways that you can debug and stuff, but this is one of the ways to do it. Exactly. You'll notice that it's not happening right now, and that's because it only runs when teleop is enabled. So let's go ahead and enable. And you'll see that there's all these values that are popping up. And as I move the control stick, you can see that it changes. And so this is doing exactly what I want. So this code in here is getting the value that I want. So that's just a way to verify that I actually know what's going on. And so now I'm pretty confident that I can take this value and I can actually put it in that set function. So let's go ahead and do that. So I'm going to copy this. I'm just going to put it directly into this set. And I'm also going to remove this print statement since we don't really need it anymore. And I'm going to go ahead and deploy. So now, once again, I have to enable for the motor to move, but let's do it. So I'm going to go ahead and enable. And you can see it's doing what I want. When I move the stick, it's changing the speed of the motor. And so obviously this is useful if you want a robot to like drive depending on the joystick. That's a way to do it. If you want to speed up a flywheel or something, that's a way to do it. You know, this is the essence of why code is actually useful.
This is where everything starts.
This is where everything starts. And yeah, any questions on that now? And I guess this is also an answer to your question, is documentation is how you know what's going on. So, I mean, the way I made this presentation is I went into the WPILib documentation and I read it, and I went to the Phoenix 6 documentation and I read that, and from that information, I can create the code that I actually want to happen. And there's also these examples that I showed before when you create a new project, and those are also super useful. They're well structured and good for reference. But yeah, so if this interests you at all and you had a good time, I would highly recommend you join our Slack. And this is sort of a communication app that we use. It's similar to Discord if you've ever used that, just sort of a messaging program. And our channel is called ProgMain, Programming Main. And I'll be posting sort of weekly challenges that I want you all to try. And if anyone needs any help or anything, this is the place to go. And you can also personally direct message me, Grady King, or someone like Sean Lee, or Bill Stanton, who is the other programming mentor. But that's pretty much all I have. My challenge for you is next week, before the next presentation, is to have Java code that controls this Falcon 500 to move it at 20%. And actually, I'm going to remove the SRX. But I'll be posting that challenge in Prog main, and I also have a few other challenges that are past that for anyone who wants them. But yeah,
Where is this posted?
Well,
I'll be posting this in Slack. I think
I'm already on it.
you're already on it. You can scan the QR code if you want to join. It's an app, but it's also a computer program, so you can do either or. That's all I have. I'm actually in time, so that's sweet. Thank you. All right. I guess we can pack up and go back down.